All right, class, this is your last discussion of the course. I know y'all are excited about that. I just want to do a short video to walk you through how to do the discussion to make sure everybody's all set and can maximize those discussion points in this final week. So we finish out the module, and last week we focused on estimation, calculating the margin of error. And in the discussion, if you recall, you were asked to create your own hypothetical data set. So you had to go into Excel and create your own numbers. In Unit 10, you will not need to calculate your original data set. What you're going to be doing is just providing hypothetical values for the mean and the standard deviation. And where last week you only were working with the margin of error formula for means, this week you'll be learning how to do margin of error calculations and confidence interval calculations for proportions, which are really just essentially percentages. So as a result, the discussion this week is going to have two parts to it. And in the first part, well, actually, first of all, notice it gives you both formulas, just like it did last week. But remember last week you only used the one for means. So here's our reminder. You see it on the screen, our formula for calculating the E, which is the margin of error for means. So that would require a quantitative variable, since means only make sense for calculating them with quantitative variables. And then here's the formula for calculating the margin of error for proportions or percentages. So with that, we would typically have some sort of qualitative variable. So that's why you see that the discussion this week has two parts, numbered 1 and 2. So for part 1, you're going to use the formula above for means. You'll be using this one for part 1. And you're going to calculate the E first, the margin of error, using this formula, but then go ahead and use the margin of error that you calculate, and then calculate the 95% confidence interval, which is your interval estimate for what you believe the population mean would be. It's an interval where you believe the population mean would be if you could reach the entire population. So you'll be doing two things. You'll calculate the E, margin of error, but then you'll use that value to then get the confidence interval. And so while you don't need to create an original data set, you do need to invent and tell us, write down in your post, the sample size, making sure it's 30 or higher. You need to also give us a hypothetical sample mean and a standard deviation, and then show us how you would use those values that you chose to calculate the margin of error and then to calculate the confidence interval. Okay. For part 2, you will do the same thing, but since part 2 is for proportions, percentages rather than means, then you will now have to invent a sample size again, making sure it's 30 or higher, but now you'll create a sample proportion, which is like a sample percentage. And I'll give you two hypothetical examples myself in this video to help you kind of have an idea of what to pick. All right. So let's go ahead and get started. I'm going to show you by hand how to do it, as you know, with a calculator, as well as how to use the worksheets that are provided for you for both confidence interval for means and for proportions, if you would like to use the worksheet to either check your answer or to help you actually do the calculations. All right, so let's start with part 1, where we're looking at means. And I'm just going to go to a Word doc, and I'm going to let my hypothetical variable, be, it's got to be quantitative, because remember, means only make sense for quantitative variables. So I'm going to let it be exam grades. Maybe hypothetically it's a class of my students and what they got on their exams. Okay. But I don't need to give the raw data, so I'm just going to remind myself that all I need is to give the sample size, the sample mean, and the sample standard deviation. So that means the sample size I'm going to pick has to be at least, 30 or higher. I'm going to just use 40, so assuming there's 40 students. The sample mean, which would be the mean exam score of the 40 students that were in my sample, and I'll just go ahead and let that be a 92. and then the sample standard deviation, which you also need as part of the formula. And I'll just let that be say a 5. Okay. And then you want to remember that the formula here is this one. So bring this back. Here's the formula, and I'm going to show you by hand what we would, what we would substitute into the formula. So we would have 1.96 times the S, which is the sample standard deviation, and I've chosen 5 for that. So times 5, and then divided by the square root of the sample size. Well, notice my sample size I chose was 40. Okay. So, and this is a nice way to write it up too, where you've specified all your values, you've showed the formula, showed what you substituted in, and now we're going to do the work. So a nice calculator to use is Web 2.0, which you see on your screen. You don't have to use it, but it is a nice one to use. A lot of students use it. And so let me bring that up here, move it aside so you can see what I'm putting in. And so here's what I'm getting ready to put in. I've got 1.96 times a 5, which was my sample standard deviation, divided by, I'm going to hit the division button. And then for square root here, it's this button right here. So I'm going to click square root. Notice it actually even uses the SQRT notation. And I'm taking the square root of 40, which was my sample size. Close off the parentheses and then press equals. And I'm going to round this off to, roughly about 1.55. If I look to the right, it's a 9, so I'm going up 1.55. So clear that out. That's how easy it is to use Web 2.0. And then to get the confidence interval, I have got to do X bar. I've got to get my lower and my upper bound. So to get the lower bound, I've got to do my X bar, which is my sample mean, minus the margin of error. Well, that's just going to be my X bar, or sample mean was a 92, minus the margin of error that I just got. And if I put that in a calculator, I would get 90.45. I'm then going to do the upper bound as well and take X bar plus the margin of error, which would be the 92 sample mean plus the 1.55. And I would get 93.55 there. And there's your confidence interval. So, essentially what you're saying is that you are 95% confident that if you could reach the entire population of all students who take this class, that you believe the true mean of all students would be somewhere between a 90.45 and a 93.55. All right. So in other words, it's an indication with this confidence interval estimate that students do pretty well in this class. That takes care of part 1, but I want to show you how the worksheet provided can also help you check your work or do some of the calculations for you. So this takes us back to the Unit 9 worksheet. And this will do the calculations for you that we just did. So as a reminder, I'm going to be putting in these values: sample size of 40, sample mean of 92, and sample standard deviation of 5. So I'm coming over here and putting 40 for the sample size, 92 for the sample mean, and 5 for the standard deviation. Now notice the margin of error was not given on this problem. I had to calculate it myself. So you don't want to fill in anything there, and you just go ahead and press enter, and you'll see that the worksheet did the calculations for you, where you see that the margin of error is the 1.55 that we got. And here are the lower and upper bound of the confidence interval, 90.45 and 93.55. And that is also what we got. We were not asked to calculate sample size. In fact, we already chose our own sample size. So that last part does not apply to this calculation. All right, so that's part 1 of the discussion. For part 2, remember it's another confidence interval, but it's for a proportion. So back to the directions where it told us that it wants us, let me go ahead and minimize this. All right, so it told us that it wants us to write down and vent the sample size, make sure it's 30 or higher, and now come up with a sample proportion, which has to be a percentage of some sort of qualitative variable. So all I need is the sample size and the sample proportion. So I'm going to go ahead and let my variable now maybe be, since it's got to be a percentage, I'm going to say let it be the proportion, or otherwise known as the percentage, proportion of students who got A's in the class. That's qualitative. So I'm now going to choose a sample size, and I'll change it up a little bit, and suppose I had 50 now in my sample just to change things up. And that's all we need for, or actually, no, I need one more thing. Let me go over here and show you. Okay, so we needed to write down the sample size. We picked 50, or I picked 50, and the sample proportion. In other words, if you really did take a sample of 50 students, from that sample, what proportion or percentage had A's? But with proportions, we keep them in decimal form. All right, so suppose 85% of the class had A's. Then my sample proportion, I won't write it as 85 because it needs to be in decimal form. So I will put 0.85. Either 0.85 or just 0.85 is fine. Both mean the same thing. So that's what you'll need to show for this. I'm going to come copy paste my formula for the proportions, which is right here. All right, and then I'm going to once again show you by hand, and then show you with the Web 2.0 calculator, and then show you how to use the Unit 10 worksheet that's provided for you. So I've got 1.96 times, now you notice I need the square root early in this formula. So SQRT, open parentheses. Now the P is really a P hat, and that is your sample proportion. So that's 0.85 that I chose. My suggestion is, before you start putting numbers all into this formula, my suggestion is to go ahead of time and do 1 minus that P. So if I did 1 minus the 0.85, then I would get 0.15. And I'm going to go ahead then and put that in right next to it. I just don't like a lot of extra parentheses. It makes the problem a little bit messier and harder to get straight into the calculator. So notice I already did my P, which was really my P hat, and multiplied it by the 1 minus P. So that I'm ready now just to say divided by N. N is your sample size. And remember, in this case, I picked 50 right here. And when y'all do your post, just make sure you specify all these values. Okay, so by hand, we're going to go back to our Web 2.0 calculator. Bring that up, slide this over. So here's what I'm getting ready to show you how to put in. And I'm going to start out with 1.96 times, and then I got to hit my square root button right here, square root. And I'm going to put 0.85 times 0.15. This prevents me from having to put a bunch of double parentheses. And then divided by 50. Close the parentheses. And my margin of error, it looks like it's going to be around 0.099. Because if I look at the 8 and look to the right, it's 5 or bigger. So I'm going to get 0.099 for my margin of error. And once again, you see how easy it is to use Web 2.0. You may already have your own website that you like, or your own actual calculator that you like, but otherwise it's a really easy one. So 0.099 is the margin of error. To then get the confidence interval, I am now going to just take my P hat minus the E. Well, the P hat was your sample proportion. And remember, we chose 0.85. So I've got 0.85 minus the 0.099. If I put that into a calculator, it gives me 0.751. I then go back similarly and do the P hat, but this time add the margin of error to get both boundaries of my confidence interval. So that's 0.85 plus now the 0.099, and that gives me 0.949, so that my confidence interval is from 0.751 to 0.949. And I would be saying that I'm 95% confident that if I could reach all students who took this class, that the percentage of people who got A's would be somewhere between 75.1% and 94.9%. Now you'll notice that's a little bit wider margin of error, bigger margin of error. With percentages, proportion, confidence intervals, you really need a much bigger sample size in order to reduce that margin of error. So, typically, if you're going to choose a sample size less than 100, you're going to get a fairly large margin of error most likely. Okay, so that's how you do it by hand and using the calculator. That's fine if you want to do it that way. I'm going to now pull up the Unit 10 worksheet that had been provided for you. All right, here it is, confidence intervals for proportion. So the Unit 9 worksheet was for confidence intervals for means. The Unit 10 is for proportions. They look very much alike, but you have to remember one is for proportions and one is for means. So make sure you don't get them mixed up. Okay, so as you'll recall, my sample size for this one was 50. My sample proportion was 0.85. Since there was no margin of error given, I had to calculate it myself. I don't fill in that third green box. So I'm going to come here and put in sample size of 50, sample proportion, and make sure you put it in as a decimal, 0.85, and then I'm going to press enter. And notice the worksheet did the calculations for you. Here's your margin of error. Remember, we had gotten 0.099 when we rounded it. And here was our confidence interval, 0.751 roughly, lower bound, to 0.949 upper bound. And remember, that's what we had gotten when we did it by hand with the calculator. All right, so I hope that's helpful for you to realize that y'all can max out those scores on this last discussion of the course, and hopefully showing you some of this will also help you through those last homework problems, and of course your quiz, since you now have a quiz over both Unit 9 and Unit 10. And just remember, you can use the calculator as I've shown, you can use the worksheets, but remember there will be a mixture this week in the homework and the quiz for means and proportions, which means you've really got to read the problems carefully. Look for whether it's talking about means, so look for keyword means, or whether it's talking about proportions or percentages. So look for the keyword proportion or percentages to help you keep it straight which formulas to use. All right, have a great last week.